Vodič kroz budućnost nauke i tehnologije je serija u kojoj tragamo za najnovijim naučnim istraživanjima u evropskim centrima i predstavljamo ljude koji pomeraju granice dosadašnjih znanja. Posjetili smo Trst, grad na severoistoku Italije, smešten na raskršću kultura, jezika i ideja. Ovaj mediteranski grad je dom međunarodnih naučnih institucija i istraživačkih centara, čineći ga jednim od najvažnijih naučnih čvorišta Evrope. Od teorijske fizike preko neurobiologije pa sve do naprednih tehnologija i eksperimentalnih istraživanja materije pomoću svetlosti, Trst okuplja vrhunske umove iz svih krajeva sveta. U Vodiču kroz budućnost zavirit ćemo u institucije kao što su Međunarodni centar za teorijsku fiziku Abdus Salam, Međunarodnu školu za napredne studije, Area naučni park sa brojnim istraživačkim centrima. Pođimo redom. Prije nešto više od 60 godina, tačnije 1964. godine, ovde u Trstu, osnovan je Internacionalni centar za teorijsku fiziku. Sa idejom da se na vrhunskom nivou istražuju fundamentalna naučna pitanja i da se mladim istraživačima, bez obzira iz kog dela sveta dolaze, omogući pristup savremenim naučnim znanjima. Dokle su u realizaciji te ideje stigli, došli smo da vidimo na licu mesta. U ICTP-u nas je dočekala Asija Jelić, koja je u rodnom Beogradu diplomirala fiziku, doktorirala na ETH u Cirihu, postdoktorske studije završila na Sorboni u Parizu, usavršavala se na Univerzitetu Sapienza u Rimu, a poslednjih 10 godina u Trstu radi kao naučni istraživač i predavač statističke fizike i biofizike. Kako red nalaže, prvo smo zakucali na vrata direktora kako bismo saznali šta ovaj međunarodni centar i naučnike u njemu čini tako posebnim. Hello, profesor.
Dobro jutro.
Dobro jutro.
Dobrodošli u ICTP.
Kako znate naš jezik?
Ja živim in Slovenija, zato ker žena je Slovenka.
A vaša supruga je Slovenka?
Moram, zato ker tašča samo govori slovensko.
So you have to know the Slovenian. That's very nice. And also?
So we met actually the first time in Paris when we were both working in a laboratory, the same lab. And actually the first day, my day there, I met Atish at lunch. I didn't know him. And the first thing he says, also with another colleague, was Dobar dan. I was completely confused. How come in Paris an Indian guy salutes me in Serbian? But then I discovered the story. And now we are here at ICTP, also closer to Slovenia and to Serbia. And so, this is the story.
So actually, we have known each other for 20 years.
Yes, it's 20 years almost.
Atish Dabolkar rođen je u Indiji, doktorirao je na Princetonu, radio na univerzitetima Rutgers i Harvard, kao i na Kalifornijskom tehnološkom institutu i u CERN-u. Predavao je na Tata institutu, najprestižnijim u Indiji, kao i na Stanfordu i Sorboni. Pre nego što je postao direktor ICTP-a, bio je rukovodilac Odeljenja za visokoenergetsku fiziku, kosmologiju i astročestičnu fiziku.
ICTP, which is the International Center for Theoretical Physics, is a very unique institution in the world. I have been around the world and I can say that there is no other institution which does the same, because it combines excellence with inclusion. It was founded by the physics Nobel laureate Abdus Salam who got the Nobel Prize in 1979. But now, last year we celebrated 60th anniversary of ICTP, so it was founded in 1964. And the idea of the center is to really, as an international hub for doing science, to bring scientists from all over the world together. Every year we get 6,000 scientists from all over the world. 2/3 are from developing countries, 1/3 are women. And the idea is to really bring the top scientists, several Nobel laureates come here often with some young, bright researcher working in a corner of the world so that science becomes global. This is the fundamental mission. And we have contributed to several major breakthroughs in science also. So excellence is equally important, including to maybe 5 or so Nobel Prizes and several other breakthroughs. And now, originally we were in theoretical high energy physics, which is what Salam got the Nobel Prize for. I also work in a similar field. But since then we have expanded in many other areas of science, condensed matter physics, which deals with, let's say, superconductivity, quantum information theory, which deals with quantum computing, is part of technological applications, climate modeling, earth system physics, quantitative life sciences, mathematics. So now we have a much broader, even though we are a center for theoretical physics, we are really an international center for theoretical sciences.
Pakistanski fizičar, Nobelovac i osnivač Međunarodnog centra za teorijsku fiziku u Trstu, Abdus Salam, bio je ne samo briljantan zahvaljujući kome je stigao do vrha svetske naučne zajednice, nego je bio i vizionar u promovisanju ideja da nauka treba da bude dostupna svim zemljama. Danas je ICTP mesto gde se susreću naučnici iz celog sveta, a Salamova misija da talenat ne zna za granice i dalje živi.
Now we are at Professor Salam's office. This was the original furniture of his office, and the library has been appointed to preserve his personal library. And moreover, we had the task to collect some pictures from his life. One of the most precious album we have is the collection of the pictures from the ceremony of the Nobel Prize Award he received in 1979. He shared the Nobel Prize with Weinberg and Glashow for their study on the unification theory. Here we have the pictures with the king. He was dressing his traditional suit because he was very proud of his Pakistani origins. And here we have pictures from Professor Salam's when he was young. This was in 1940, and this picture is from the journal where he first published a scientific paper when he was 15 years.
Međunarodni centar za teorijsku fiziku, ICTP, osnovan je pod okriljem UNESCO i Međunarodne agencije za atomsku energiju u partnerstvu sa italijanskom vladom. Više od 6 decenija se razvija praveći iskorake u neistraženim oblastima fizike.
So we are not a theoretical institution. We are not like CERN, for example, in Geneva, where there is a huge accelerator. We do blue sky research. We do completely curiosity-driven research. And that is actually our strength, because I sometimes joke that we are like a CERN with a blackboard without an accelerator. We don't have an accelerator, we just have a blackboard. And you will see in our terrace, a lot of students are, even now if you walk by, lots of students and postdocs and scientists are working on blackboards. That's what we do. And what Salam realized, and which I agree with him because I also come from India and have seen science in developing countries, that fundamental science is very crucial to technology. I mean, oftentimes in the popular mind, people want to think about some exciting developments. But you see, if you look at your iPhone, the technology that goes into it depends on quantum mechanics, which was invented 100 years ago in universities. Quite abstract sounding physics, actually. Even before that, Maxwell's equations, which are used for propagation of electromagnetic waves, semiconductor physics, which depends on quantum mechanics, lasers, all this amazing technology, or internet, which was actually not discovered, it is a technology that was developed at CERN. So research and investment in research, fundamental research, is quite important also for technological development. And that was the argument that Salam presented to the UN bodies, that for development in a developing world, if a country does not invest in science, first of all, you lose talent, you lose very brilliant minds, and you will only be a consumer of technology. You will only be importing. You won't be creating. And that's what is the goal.
Dr. Asja Jelić je deo grupe za čvrsto stanje i statističku fiziku na ICTP-u. Bavi se istraživanjima u oblasti aktivne materije, pre svega kolektivnog ponašanja životinja i ljudi i generalno odgoneta tajne kompleksnih sistema.
Na početku naravno nisam znala tačno šta me to tačno interesuje. Znala sam samo da me jako interesuje oblast statističke fizike, koja je oblast fizike koja se bavi sistemima koji se sastoje iz jako mnogo čestica, koje sve zajedno interaguju i ono što se dešava je da oni zajednički ostvaruju neka svojstva koje su na makroskopskom nivou. Počela se razvija ta jedna oblast koju danas zovemo active matter ili aktivna materija. To je oblast koje statistička fizika može svašta da kaže u toj oblasti, zato što su to entiteti, mnogo entiteta ili individua koji nekako crpe energiju, da li iz hemijskih, iz okoline ili preko hemijskih nekih reakcija, i uspevaju da se pokreću, svaki entitet, svaka individua zasebno. Kada imamo mnogo tih individua, stvaraju se potpuno neki novi magični procesi koji su sad jako aktualni u fizici. Jedan od primera, na primer, su jata ptica ili takođe jata riba. Ili imamo takođe ponašanje pešaka, svih zajedno. To je naravno na tim nekim makroskopskim sistemima koji su nama poznati. Takođe to može da se vidi i u nekim veštačkim sistemima, to je jako sada popularno, kako napraviti, koje su pravila interakcije sa kojima tako neki mali roboti, mikrorobot ili nanoroboti, mogu da interaguju, ne bi li izvršili neku funkciju koju mi recimo vidimo u prirodi. Tako da eto, to je sada glavna oblast sa kojom se ja bavim.
Gde bi sve to moglo da se primeni i na koji način?
Da, pa znači, kao što sam pomenula, znači, jedna od osnovnih ideja je da se, na primjer, ta pravila koju smo naučili iz prirode primene sada u veštačkim sistemima. Znači, jedan od takvih sistema, na primjer, su dronovi. Ako imate jedno jato dronova, kako bismo mi mogli da znači, prenesemo pravila kako da oni interaguju, pričaju jedni sa drugima, ne bi li obavili neku funkciju. Ta funkcija može recimo da bude, zamislimo u nekoj nesreći, recimo u poplavama ili u zemljotresima, kada ne želimo da pošaljemo ljude tamo, ali možemo da pošaljemo, znači recimo dronove ili bilo kakve druge robote, tako da mi ne moramo da ih vodimo, s obzirom da ne znamo situaciju, ali oni međusobnom tom nekom interakcijom među njima mogu da organizuju, recimo da traženje ljudi koji su nastradali ili ma kakve druge mogućnosti možemo da smislimo. Ili recimo u medicini možemo da zamislimo te nanorobote kojima možemo da damo lek i koji stavljajući ih u naš krvni tok mogu da tačno targetiraju ćelije kojima je potreban lek, na primjer kancer ili takve neke stvari. Znači to su neke ideje koje su trenutno aktualne, da.
Na ICTP-u, osim teorijskom, bave se i primenjenom fizikom. Grupa istraživača pod vodstvom Marka Zenarija, stručnjaka u oblasti interneta stvari i bežičnih senzora, na Odeljenju za nauku, tehnologiju i inovacije, posvećena je pronalaženju održivih rešenja za zemlje u razvoju.
We started about 20 years ago dealing with telecommunications. So most of the universities in developing countries were not connected to the internet. So we assisted them, especially using wireless technologies, to get better connectivity to the internet. Then things evolved. There still about a third of the world population is not connected to the internet, but many universities now do have connectivity. So we focus on what is called the Internet of Things. So providing data, sensors, that then travel on the internet and that provide useful information to the scientific community. And now the latest focus is on something called tiny machine learning, which means that small devices, such as this one that I'm holding here, can now run artificial intelligence on these small devices. So this is a bit different from what is currently known as AI, which, as you know, is in big data centers, very power hungry, very expensive. So developing countries, which we deal with, and scientists in developing countries, cannot afford getting access to these big servers and big systems. So there's an alternative model which allows artificial intelligence to run on small devices for specific application. So we have a big community of researchers working on this in developing countries. We have a network of over 60 universities, and they work on many diverse applications. So just to name a few, we have colleagues in Peru that use the camera on these devices to detect if people have anemia by scanning their eyes. We have colleagues in Africa, I'm just back from Malawi just yesterday, that work with the microphones on these devices to find out if there's insects in big containers of maize or of corn. So this is a big issue because these big containers get rotten because of the insects. So being able to understand through AI at an early stage if there's an insect inside through the microphone is really important to be able to then, use the maize and the corn. Microphone on board, a light sensor, and an accelerometer. So you can, again, use the camera for some application, but there's other applications.
This is a camera?
Yes.
And where is the other sensors?
The sensors are here on the board. I think this might be the processor. This should be the microphone. But of course, you can also add other sensors. So then there's people that want to add additional sensors, which you need to connect, of course. But for example, you can have, again, light or, more specific sensors. So we have...
It's an indoor light sensor.
Yes, exactly. Or we have like application with the Atomic Agency, where we use this to understand, to connect to some radiation sensors, and we can understand what kind of radioactive source you have. So as much as you have these sensors on board, you can still add additional sensors if you want.
And these ones are all the same?
They're all the same. This is the antenna. So in some cases where you want to send the result through Wi-Fi, you can still do that.
Also?
You can do that, yes. Yeah. Internet of Things is about collecting data. So normally the process is that you have a device that collects some data through some sensors. You send the data to a big data center, you analyze the data, and then you send some result back so that so-called actuation on the device. Actually, this has been, proposed as a process to get a lot of information about the environment, but it has failed in some way. Of all the data we gather every day, it's 1 quintillion bytes, which is 1 with 12 zeros, so a huge amount of data. We only analyze about 1% of that data. So 99% of data is wasted because it is so expensive to send data and then to analyze it. So the big advantage of TinyML is that you actually analyze the data as close as possible to the place where you gather the data. So you don't waste any of this data. You analyze it immediately and you decide what to do. Well, that's a big advantage. And in fact, again, being able to analyze the data on the device means that you don't need to send it. And sending data is the most expensive part of the whole process.
Na koji način naučnici u ICTP-u sarađuju i jedni druge inspirišu, pokazuje primjer novog projekta koji se tiče vode, a koji je nastao na osnovu istraživanja Asije Jelić.
My name is Ali Hassan Ali. I'm a senior research scientist in the Condensed Matter and Statistical Physics group. My own focus of research is in using computers to study liquids, in particular water. So my collaboration with Asia started right around COVID or before COVID. I got inspired by a seminar that she gave on looking at collective behavior in birds. And when I heard her talk, I was sort of asking myself, could we apply similar ideas from statistical physics to study the physical chemistry of water? And that got us starting and interacting. And it turned out that many of the ideas there could be applied to understand the complexity in water.
We started discussing, and actually it is exactly things that interest me most, to be inspired by new problems, but by using my old methods. And so we started first discussing about what happens in water, actually. And actually what happens is that molecules of water are making some large jumps, so they just suddenly turn around, We tried to identify them. So the question was which quantities we should use, which variables we should use, how we can put all this together and understand whether there is actually some collective phenomena. So that was quite long work. We had to first make a program to understand these things, and actually this is where our collaborator Natalia helped us a lot with her background.
I'm a programmer before, and when I come here, we start interested with this collective behavior of water molecules. And at that time, it was an article which already was published, but I did change the program a little bit and did this behavior for another problem and start develop this solid code which was partly used before, but then I improved them.
One of the results of the collaboration was that we published a paper together in Nature Communications, which has been received rather well by the community, and there's a lot of interest. And number two, thanks to Natalia's involvement, who managed to take our code and optimize it, it is now in a shape that I believe will open up some other future directions of research and applications.
Na ICTP-u se čuva tradicija i neguje izvrsnost u nauci. U tom duhu osnovana je i prestižna nagrada Paul Dirac.
The Dirac Medal is a very prestigious medal given by ICTP. Paul Dirac was one of the greatest physicists, one of the top in the world in the 20th century, one of the founders of quantum mechanics, inspiration to many of us. And Salam actually, he was at Cambridge, so Salam knew, he used to visit ICTP several times, so he became a very good friend of the center. So after he passed away in his honor, starting 1985, we founded this Dirac Medal. Since then, several very major figures in our field have received this. Many of them have gone on to win the Nobel Prize or to get the Fields Medal. For example, here the first one was given to Edward Witten. He was my professor in Princeton, actually, and one of the great physicists of our generation. And Yakov Zeldovich from, at that time, the Soviet Union, one of the great Russian physicists, Soviet physicist, who has made wide-ranging contributions. And consistent with ICTP's mission, you can see that the prize was shared by somebody from the East and somebody from the West.
Ovde se nalazimo pored glavne zgrade instituta i ovo su takozvane Diracove stepenice. Paul Dirac je engleski matematičar i fizičar, jako je bio dobar prijatelj centra i bio je vrlo često gost ovde. I ove stepenice nose njegovo ime zbog toga što legenda kaže da je jednom šetajući se parkom Miramare se sapleo ovde i pao i tako su mu dodelili ove stepenice kao neku uspomenu na njegov boravak ovde.
Diracove stepenice vode direktno u Miramare park, što je, čini mi se, jedna od velikih prednosti rada u ICTP-u.
Da, tačno tako. Čak i pre nego što sam došla ovde, ovde sam već 10 godina, pre toga sam često dolazila na konferencije. Naročito leti. I to je bilo jedan od najlepših iskustava, zato što smo tokom pauza mogli da dolazimo ovde da siđemo na ručak, na kupanje. Tako da je to zaista veliki adut našeg centra, da se nalazimo na ovako lepom mestu.
Vi držite kurseve studentima, ali to su jednogodišnji kursevi koji nisu doktorski, je li tako?
Da, to nisu doktorski, to su recimo predoktorski, mogu bih da ih nazovemo. To su znači studenti koji su, iako su završili već svoje studije fizike ili matematike u svojim zemljama, zapravo dolaze ovde da bi napredili malo to svoje zvanje i stekli znanje iz oblasti u kojima oni nisu imali prilike da se obrazuju u tim oblastima. Tako da im dajemo praktično jednu šansu da dopune to svoje znanje i na taj način imaju kvalifikacije da apliciraju za doktorske studije svuda u svetu.
I come from the southern part of Africa, Zambia. I completed my bachelor's in physics in 2023. and I'm currently studying the condensed matter diploma program at ICTP. So I decided to be here so that I prepare myself for my postgraduate studies, for my PhD, which I'll be probably doing next year.
And I come from Vietnam. I came here for the study in the diploma program for this 1 year. And currently, right now, I'm planning for the next 4 years to study in CISA in CISA in Trstu. So, well, I expect for this program, I can learn more about the international environment in ICTP, and then using that experience to continue for further study. And when I have enough experience, I can come back to my country to helping in develop the academic environment and educate the new generation of the physicists over there.
I am from Pakistan, and I have done my bachelor from a good university in my country. And then from there, from the professors and everyone, I got to know about ICTP. So ICTP is very known in my country, in Pakistan. Everyone knows ICTP. So I got to know from the professors, and then I decided to apply for this postgraduate diploma program in condensed matter physics. And now I already have a PhD position in CISA. In condensed matter physics, so I will join that for the next 4 years. And then I want to work on more quantum-oriented things like quantum optics and light matter interactions and these kind of things.
What are the opportunities for Serbian researchers and Serbian young people?
So ICTP has had a scientific connection with the Balkan region for many years. And I'm trying to strengthen it now. So one of the 2 new initiatives that I have launched, one is an International Science Alliance, and the other is International Consortium for Scientific Computing. So the second one is for addressing all these exciting progress in AI, let's say, in machine learning, quantum computing, how to make it available. You don't want this technology to be locked in a few countries or in a few companies, but you want scientific community at large to be able to use it. And so this consortium is an idea. It's a consortium, so many people can join. We've had now some very good agreements with South Africa and with Brazil, maybe also with India, we will see. And for example, Balkan country would be most welcome to join us.
Kako naši istraživači, naši studenti da dođu ovde u Trst, u ovaj institut, kako da, ne da se zaposle, ali da upravo steknu ta neka dodatna znanja koja će im otvoriti dalje istraživanje, neke mogućnosti.
Da, ima više mogućnosti. Osim redovnih programa konferencijskih, gde svako može da se prijavi i da dođe, što je dosta jednostavno. Ima također nekoliko programa za istraživače, kako mlađe, znači doktorante, tako i starije. Naprimjer, postoje programi sa našim institutom gde doktoranti mogu da dođu svake godine, recimo po 3 meseca, koje provedu ili na našem institutu ili u nekoj drugoj laboratoriji, čak i u Italiji, ne samo u Trstu, i u saradnji sa nekim lokalnim profesorima. Za istraživače starije, recimo postoji program, to se zove Associates program, i zapravo postoje nekoliko srpskih asocijeca u našem institutu koji onda imaju mogućnost da svake godine dolaze po mesec ili po 2 i sprovode svoje istraživanja, što im u ovom dobrom ambijentu naravno nije teško. Znači malo nemaju toliko obaveza kao što imaju u kući, u svom okruženju u Srbiji. Međutim, mogu da se posvete istraživanjima, da upoznaju kolege iz raznih delova sveta i tako na neki način napreduju.
Koji bi vaš bio direktan savjet mladim ljudima u Srbiji, ljudima koji su zainteresovani za naučne istraživanja, s obzirom da je ovo institut koji je posvećen fundamentalnim naučnim istraživanjima, iako smo videli jedan segment koji ima i inovacije, i jel tako?
Pa da, mislim da je glavni savjet da budu otvoreni i da probaju da skupe što više iskustva, također internacionalnog. Znači, ostati u Srbiji, naravno, ali sa mnogo tih iskustava, posjeta drugim zemljama, drugim institucijama. I prosto to je ono što čini nauku tako interesantnom, jer jedino na taj način možemo, gledajući i slušajući ideje iz raznoraznih područja i također naučnike iz drugih zemalja, možemo da unapredimo ono što mi radimo i da nam dođu neke potpuno nove ideje o kojima ranije nismo ni razmišljali.
U sledećoj emisiji vodimo vas u Međunarodni centar za genetičko inženjerstvo i biotehnologiju, koji se nalazi ovde u Trstu, između ostalog i zahvaljujući našem najpoznatijem genetičaru, profesoru Vladimiru Glišinu. Budite sa nama i sledeće nedelje.